today. On behalf of your hosts, Engineering USA and Siemens Digital Industries, I want to welcome you to our webinar focusing on advanced planning and scheduling technologies for Industry 4.0. In the next 45 minutes, we're going to explore the tools and methodologies we believe industry leaders should be looking at if they want to achieve flexibility in their production and win the scheduling game for the businesses once and for all, and especially during these uncertain times. Why don't you go ahead and hit the next slide. Here's the agenda for today. First, a quick introduction to Engineering USA, our leading Siemens solution partner and expert in all things Industry 4.0. Next, a look at the big picture, a digital thread, the mom, and where the production planning and scheduling fits in. Then the main event. Our expert, Marco Lentini, will walk us through the scheduling game in manufacturing, how you can play to win. We will showcase the latest capabilities in Siemens Opcenter APS, our digital toolkit for advanced planning and scheduling. Finally, we will end with a Q&A session. Let's go to the next one. Here are your speakers for today. My name is Colin Henry. I'm responsible for portfolio development at Siemens Digital Industries. I manage the Opcenter APX product for the Americas. Next, we've got Fabio Sala. Fabio has been working in the manufacturing technology space for over 25 years. After almost 20 years with Siemens, in the last 10 years as Director of MOM Delivery Services, Fabio joined the Engineering USA team and is their Director of North America, Director of Operations for North America. Finally, we've got Marco Lentini. Marco is Supply Chain Management Practice Manager at Engineering USA. Most of his career he has spent delivering sales and operations planning projects to manufacturers of all shapes, sizes across all industry sectors. His expertise covers everything from demand forecasting to inventory to capacity planning to detailed scheduling. In the last 15 years, he has led implementations all around the world, helping manufacturers leverage technology to optimize processes and overcome their greatest challenges on the production floor. Let's go to the next slide. Now, before we get started, first, please make sure your phone is on mute. Secondly, we'll share this recording with you after the webinar. And finally, we would like to be able to have you submit questions during this webinar, but for some reason I've had a little trouble with the chat icon. So please feel free to reach out to me with an email or to Marco or Azivo, but anybody here at Engineering USA to get your questions answered. Thanks again, and with that, I'd like to turn the stage over to Fabio.
Thank you, Colin. Hello, everyone. My name is Fabio Sala, and I'm responsible of operation in Engineering USA. I'm very happy to have you here today. And first, I would like to introduce a little bit who we are, so as Engineering USA. So if you go next, Engineering USA is based in Chicago, Illinois, but is part of a much bigger organization. So Engineering Group is a global company with 12,000 employees, 65 offices in the world. And we do 1.3 billion revenue in basically implementing a solution for the customer in different business areas where digitalization can have a big impact. So like smart cities, smart energy, transportation, smart governance, digital finance or smart agriculture, digital retail, and so on. Now, Engineering USA is basically the branch for North America, and our focus is manufacturing. So we are called Digital Industry, and we are basically a software maker and system integrator, provider of technology, and our goal is providing a valuable solution in manufacturing. Yeah, you can go next slide, please. So the goal is supporting the customer in the digital transformation journey to make the future manufacturing possible. So what we implement is a digital thread within manufacturing. So we come to the customer, we analyze business opportunity, and we leverage our industry expertise in the different industry niche. and we transform processes, systems, and people, and applying a diversified portfolio of solutions following this implementation from design to configuration till the adoption of the solution in the plant. Going next. Yeah, we have a long-standing relationship with Siemens. So it's a partnership that is going on from many years. And we are specialized in different products of Siemens, from PLM simulation, MOM, MES system, shop floor connectivity, integration, cloud technologies, different kind of application. We also support Siemens with training, and we support R&D. So we basically deliver more than 200 between PLM and MOM projects in time. And we have tens of global implementation that we jointly implement with Siemens around the world. So next, please. Here is our vision. So implementing digital thread for Industry 4.0. And you see this Industry 4.0 represented in 4 main pillars. Now going from the left to the right, we start from design. So where we design the product and the processes. Here where mainly the solution for product lifecycle management resides. Then we move to simulate, where we simulate the process, the plant. We implement the digital twin to optimize process plant supply chain with a simulation product. So today we are really focused on produce, where we execute and we control production. So here are all the software in the plant that support of operation. And today the focus is really on manufacturing execution and understanding how the scheduling tool can support in optimization of the performance of manufacturing in the plant. Last but not least, we have utilize pillar. Here is where we monitor and we service the product when it's outside the plant. He left the plant, is outside in the field. No? And we do this basically through digital enablers, which are technology and enabling services that allow us to really connect all these things in a digital thread. That is what we call Industry 4.0. So go next. Now, today we are really talking about how to obtain a flexible production. So how to have accuracy and efficiency of a production schedule, of course, has a huge impact on the business results. So to create a good production plan is very important, and we need to take into account all the different constraints that we have in production, like material availability, the capacity of the line, the machine, the demand, the supply, the operator availability, and so on. So all these constraints are actually not static, so are something that continuously change. And so if we want to operate effectively, we need to have a plan that is adapting to this change as well. So on top of that, a lot of industry are going in the direction to have configurable products. So products that are more and more different each other, the kind of mass customization. And this, of course, is also increasing all the constraints that we need to apply to our production plan. And now if you go next. So now this is the situation we are living today. Of course, the current crisis has shown that unexpected changes in demand and supply can happen and really bring the entire supply chain under chaos. So now is even more important now to have the possibility to map the constraints, to have the capability to understand, first of all, what is happening, and also adjust the operation accordingly is now becoming really vital for managing the production in a flexible way. No? And this is what Marco will talk about in the next session. So we'll really tell us how all these things can be considered dynamically in a tool, and how we can really win the scheduling game for smart manufacturing. So please, Marco, keep going.
Thanks, Fabio, for the introduction. Welcome, everybody. My name is Marco Lentini. I'm practice manager for supply chain management at Engineering USA. So today we're focusing on Opcenter APS. Opcenter APS is a suite of software that cover finite capacity production planning and detailed scheduling. So first of all, let's make a little bit of clear what's the difference between scheduling and planning. Planning, the first difference is horizon. So planning is aimed to fix problem and give solution and give answers to what's happening in the next 6 months, 1 year, so long range period. Less detail, but basically answer question as what to make, where to make it, how much to make it, okay, and when to make it. Scheduling, on the other side, is focused on much more detail and less time horizon. So it's more focused on what's the best sequence to produce, to accomplish my production plan, what's happening on the production floor and how can we react, and so on. To do that, we have to create our model. The model is composed by a mix of your resources, your constraint, your processes, and your calendars. Okay, and mix them together, we can compose this model that give us one main target that is our focus always when we schedule, that is to give a feasible production schedule and executable by the production line. Okay, so our main focus of the detailed scheduling is to give a truly feasible, executable production schedule. What means with the executable means that all the constraints are respected and my production line can start with the next operation that is highlighted by my schedule, my production plan. To do that, we collect data from different sources. The two most important ones are the ERP and the MES or SCADA system or some kind of control of the production floor, where we can get from the ERP system, we get orders, and they can be production order, sales order, work order, purchase order, any kind of order, stock availability, calendars, people, and actual availability of things. On the other side, from the MES or a production floor controller tool, we can get updates on how our order are being executed. So there is a breakdown on the line. My order is in time, is early, is late. So that to mixing all this information, we can produce our schedule, our production schedule, our production plan, depending on how you call it on in your company, that is both executable, and we can send it also back to our ERP to update the demand, to keep in contact with the customer so the customer can be aware of what's happening and how is going to be fulfilled this demand. Okay. So my plan for today is to walk you through 5 different scenarios, 5 different use cases to show you how your company can leverage this tool to accomplish a better production plan and a better production schedule. Okay. My first use case is what's called setup minimization. As the title says, setup minimization is one of the logic that we can use to schedule. What I mean by that? When we schedule, we use different logic, different algorithms, different heuristics, depending on the tool and the capability, that have different target in mind. We can target an early delivery date, like the first case in my slide, where we try to accomplish our need date as a first, or we can try to optimize our processes and try to minimize our setup, like the last case. Obviously, rarely these two extreme are the right answer for any company. Usually we go in the middle to get a compromise to understand what's the best solution for your company. And with that said, I would like to switch directly to the tool so we can see live what it looks like, okay? This is the Gantt chart of Opcenter APS. And we can see that we have all our resources here on the left. We have the time going from left to right in a continuous mode. And we have information about supplies here on the header and about demand here on the bottom. We have a list of unscheduled operations. And what we can do is take them. Automatically, the system knows where an item can be produced and where not, as you can see. And we can drop it and schedule it according as we like. Okay. And we can go on, and the system is taking into account all the constraints, the calendar, as you can see, the light blue or gray is when the machine is off. So it's the calendars and so on. Obviously, this is quite time consuming, and I would suggest it. So what we can do is utilize and leverage the automatic logic that I was talking about, okay? So we have a list, we have forward sequences with different options, backward sequence with different options, bidirectional sequence that's mostly used for bottlenecks, and advanced rule, okay? For example, let's try to do the most standard one, forward by priority. And we see that our production plan is filled in less than a second with all my order. And if I click on an order, I can see where the order, all the operation of the order, and to which other orders is linked this order. So for example, order 18 produces the item Z and is going to fill order 15 that produce item C3 that fills two different purchase order here, okay? But we'll see that in a minute. Let's focus for a second on the scheduling logic. So with this logic, so I want to schedule first what has more priority. I get, for example, 22 order lays, a total setup time of 18 days and almost 19 days, and a schedule span that is from the first order to the end of the last order, we have 101 days, okay? So if I try to rerun it with a different approach and with the setup minimization approach in mind, I have an option to say that how much should I look. And we can see at a glance that we have a strong reduction of this black box that are our setup time. And if I go into the schedule statistic to look at my KPIs, I can see that now I have only 1 day and almost 2 days of setup time. So I got a reduction of almost 17 days of setup. My schedule span is smaller because I went from 110 to 106, but I have 4 more orders late. So here is the trade-off. I want to optimize the process and gain here and here, or I can manage somehow the customer being late, or I want to optimize my customer satisfaction and deal with the higher cost in setup, crew, and etc. That's where the human scheduler gets in, and we let the tool take care of all the menial stuff to calculate all the constraints and everything, give you a feasible production plan, and you can take care of to understand which one is the best plan and leverage on the pool that you can to achieve it, okay? So with that said, obviously to have an executable production plan, we need to understand which constraint we are going to add and how. So Opcenter scheduling has 2 levels of constraint. The first level is what is called the primary constraint, and it includes the equipment, so all the machine that we saw on the left before, but also includes secondary constraints. So constraints that can be shared between different machines, for example, or energy constraints or tooling constraints, for example. But let's see it live, that I think it's clear. If you go to plot window, we have the list of all my constraints. Okay, power constraint, operator, etc. Let me schedule with my primary by priority. That's okay. So to see it better, we can rearrange our interface to have at a glance both my constraint and my production. And if I click on it, I can see exactly which operation are consuming my constraint. For example, my operators of Workcenter 1 that serves machine 1001 and 1002, or my operation Workcenter 2. And I can see that I have only one machine at the time working between 2001 and 2002. And I can go on and look at each one of them likewise. So I can see that automatically my system takes care of constraining and check the constraint. So one question could be, with this in mind, I have my schedule statistic, 21 order late, 18 days, 1 or 2 days. So what happens if I relax one constraint or all the constraints? I can run a simulation with the secondary constraint disabled, or I can disable one single constraint at a time, depending on what you want to achieve. And I can reschedule with the same exact logic. And I can see that, for example, let's see. I could use another operator in Workcenter 2 to have some gain, some parallel working here and there. And I can use another special tool. This is used down below, so let me scroll a little bit. So I can see that I can use a second special tool. So for example, I can focus on these two parameters, and I can say, okay, hiring a new person or training a new person there, or buying a new tool, how much is it costing me? What could be the difference? So I can gain something on the schedule span, I can gain on the lateness, on the earliness, and so on. So I have a trade-off, and I have to understand what's better to do, if it's worthwhile to buy a new tool to gain something, or if it's not worth it, and so on. Okay. The next constraint, one of the most important, so important that it needs a special management and a dedicated management, is material management. So Opcenter EPS has a dedicated management of materials, from raw material to sales order. So we can see at a glance how the material are flowing in my production plan in my plant. So to do that, I need to obviously fill it with information about stock, purchase order, and sales order. And automatically the tool has a capability and the functionalities that allows the link of orders between different orders according to rule that you can set directly in the tool. So if I open up on the Material Explorer on any of them, I can see, so let's zoom out a little bit to see everything. I can see that this order number 63, is using material from purchase order 04, and is using 390 of this material, produced X, that is used on 3 different orders, 65, for example, produced A3, and 280 are unused, while we have 3 sales orders that are satisfied by this production order. You have direct information of all the materials in this order what their stock level will be in the future. And you have information about what materials will be unused and what is missing. For example, I got information here that we're missing 240 items to get to this order schedule. So in order to get this order schedule, I will need to have 240 material X delivered on March 17 at noon in order to be successful with this production plan. And you can use this in different ways. You can have materials that are constrained to your production plan, so that cannot allow you to schedule an order if some material is missing, or you can use it, as in this case, as a soft constraint. So you are still allowed to produce even if the material is missing, but it's giving you an alarm and tell you exactly when you need it. So you can contact your supplier and check alternative supplier to have this material delivered in time to start the production. Okay. So you have a straight gain of control over your supply chain, and you can better react to delays. About delays, we know that our production plan are fine when we think of them, when we depict them, but then the production floor starts to execute, and then always something happens. So when something happens, you need the ability and the flexibility to react quickly and effectively, okay? So, for example, in this case, we are not connected to any system that monitors the line, but we can simulate a breakdown. For example, let's say that the first day of production, my resource 1001, sorry, is broken down. And we'll come back tomorrow at some time. So immediately I can see that I have a little wall here that depicts my breakdown, and everything has been shifted to the right without checking anything. That's the problem. So if I check this order, for example, I see that my next operation starts before this operation is completed. So this is a problem. We should fix it. And we could manually move everything and check the next one. Check step by step is like a nightmare. So we can use the validate schedule function that will tell us all the scheduling problem that we have right now. So for example, we can see operation order number 17, there is a problem between operation 10 and operation 20. You want to continue? Yes. Operation 18, another problem. Operation order 30, another problem. 38, 59. So I could write down all these orders in order to fix them manually and go in 17. I need it to start after that. This one I need to start there, and so on. Or we can leverage the tool and a functionality called repair schedule that automatically will fix my schedule, allowing me to continue my work and see that automatically it will check that everything is in sequence. And if we validate again, we have a problem on the secondary constraint, but rather than that, everything is fine. So if we can be confident that our production plan right now is feasible, okay? The last point is what if analysis. I think we already saw some capability of the what if analysis. What if I have infinite people working for me? What if I get the material delivered on time, and so on? But to better analyze it, I want to show you another capability that I think fits with everyday working of a scheduler. So let's imagine that a salesperson calls us and tells us, hey, hi, how you doing? How's the schedule? I have a customer that is thinking of buying this item for when can we deliver it? And usually the scheduler has to, okay, create the order, try to plan it, see where it can fit, and so on. And what we can do is straight in the tool, create our order, webinar. So our order is for part X, okay, is for 100, okay, automatically scheduled, and it tells me that it can be completed by in 3 months at 7 p.m. Usually, when you do that, the salesperson tells it, no, you cannot. I cannot do it in 10 months. In 3 months, I need it tomorrow. So let's see. Okay, if high is priority, and I try to schedule again. Okay. And I don't see it, so let me look for it. Here it is. Let me highlight it. Oh, here it is. So right now, my order is automatically ended by in 3 days. That's the best we can do, but we are missing 100 pieces of RMX, and we need this material called RMX delivered right now. So if we can find these, we can deliver this order to the customer on the 13th of January at noon. Is this good enough? Yes, let's look for the material and confirm it to the customer and have him send a purchase order, etc. Or no, then we have to say no to the customer. That's the best we can do, and for the miracle we'll see in the future. Okay. So with these 5 steps, we saw how you can use this tool to support your operation and support your production floor in real time with smart functionalities. Okay, so over the year, we saw how advanced scheduling can increase your throughput, reduce your work in progress, and minimize your raw material inventories and optimize your utilization of your material inventories. Okay, and over the years, we saw that with our customers, we saw that we improved the customer service greatly. We improved the productivity, and we reduced the cycle time and the raw material inventory by a big number. Okay. So to end this, I want just to say that digitalization has changed everything for manufacturing in the last 10 years or so. Okay. And the current health crisis is even brought a whole new set of issues to play. But with the utilization of tool and like Opcenter APS, you can greatly increase your chance to win this game and this, as we call it, this scheduling game for the business much more easier than without those tools. And with that said, if there is any question?
Oh, Marco, this is Carlos Artalejo. I have one question.
Sure.
Does the tool offer capability to manage alternate bombs and alternate routings?
Alternate bombs? No. We have the current bomb, and you have to select for each order which bomb to use. So you can use multiple bombs, but it doesn't select automatically which alternate bomb can select for each order. You have to give the information to the tool which bill of material to use on each production order, actually, on each work order. Okay.
Same token for the resource. So we have alternate routings or resources.
Absolutely, yes.
Okay, very good.
Absolutely, yes. You can select the subset of machine where each order can run with different speed, different constraint, different everything. And automatically the tool will select the best one for that run.
Thank you.
You're welcome.
Do you assume transfer delays between operations?
You can. Is a standard feature of the tool to you are able to insert in the for each production order or for each routing a standard delay or a specific delay between operation, and can be a transfer delay, so it's fixed, or can be a setup delay, let's say. So depending on the sequence of the orders on the machine, you have different delays.
So how do you confirm that the schedule you produced at the start of the shift is actually valid, say even 15 minutes later? Because you can program a transfer delay between operations, but anything could happen, and what you put as 15 minutes could be 45 minutes. How
Absolutely.
do you?
So we make assumption. So remember, the schedule tell us what's gonna happen in the next 3 weeks. So we have to assume
Okay.
some standard time. Then with connection to some execution system, we can receive automatically what really has happened on the floor and adjust the schedule accordingly.
So one last question.
Sure.
Which manufacturing execution system do you support? Machine Metrics, 4CAM? Because I see a difficulty here. It's a great scheduling tool, but how do I know that it is up to date, and every time I revise it, I can't wait for the office scheduler to send me a new schedule?
So that's more on the integration part, and we can integrate with any system. Basically, the tool obviously is natively integrated with Opcenter MES, the Siemens product, and Camstar. No, Opcenter Farm. I don't know the new name, and sorry about that. Sorry, Colin. So all the Siemens portfolio is natively integrated with the system, so automatically you know that you have the latest information every time, because every time that you open the schedule, it automatically checks what the latest information available. If you have to integrate it with different tool, we did it in the past, is not a problem. The tool comes with a nice integration feature, and you have to be careful to during the project make sure that the integration happen and the import happen every time you open the tool. Did I answer your question?
I was hoping if I can have your email address, because this is a long conversation. I am interested, but I know there are 47 other participants.
Marco, go to the slide with your emails as well. Maybe put that up so that people can.
Here you can find the. I'm Marco Rentini. Here is my email, and you can read
Thank
me
you, sir.
out.
Thank
Without
you.
any problem, we can have a longer discussion one-on-one.
Yes, sir. Thank you.
No problem. Any other questions? If there are no more questions, I'll wrap up this webinar. I want to thank you, everyone, every and each one of you, to attend this webinar. And if you come up with some question while you think about it, or I know you can review the recording that we will send out later today or the next day. And if you have any question, you can reach out to our email. And have a nice day and stay safe.
Thank you, sir.
Thanks, everyone, for joining us today.
Thank you.
Thank you.
Thanks for hosting.
Okay.
Thank you.
Thank you.
Thank you very much.
Thanks, guys, everyone.